Hello, welcome to Engineering Tuitions. This is the third session of this subject and this is the overview of the topics which includes angle modulation, frequency modulation, phase modulation and generation of narrowband FM. So let's get started at today's session. The other type of modulation in continuous wave modulation is angle modulation. Angle modulation is the process in which the frequency or the phase of the carrier signal varies according to the message signal. The standard equation of the angle modulated wave is St is equal to AC cos θ, where AC is the amplitude of the modulated wave, which is the same as the amplitude of the carrier signal, and theta it is the angle of the modulated wave. Angle modulation is further divided into frequency modulation and phase modulation. So frequency modulation is the process of varying the frequency of the carrier signal linearly with the message signal, while phase modulation is the process of varying the phase of the carrier signal linearly with the message signal. Now let us discuss these in detail. So starting with the frequency modulation, in amplitude modulation, the amplitude of the carrier signal varies, whereas in frequency modulation, the frequency of the carrier signal varies in accordance with the instantaneous amplitude of the modulating signal. Hence, in frequency modulation, the amplitude and the phase of the carrier signal remains constant. This can be better understood by observing the following figures. This is the baseband signal according to the instantaneous amplitude of which the frequency of this carrier signal is going to be varied, resulting in this frequency modulated wave. We can see in this figure the frequency of the modulated wave increases when the amplitude of the modulating signal increases. Similarly, the frequency of the modulated wave decreases when the amplitude of the modulating signal decreases. Note that the frequency of the modulated wave remains constant and it is equal to the frequency of the carrier signal when the amplitude of the modulating signal is 0. Now mathematical representation. The equation for instantaneous frequency Fi in FM modulation is Fi is equal to Fc plus Kf into Mt, where Fc is the carrier frequency, Kt is the frequency sensitivity and Mt is the message signal. We know the relationship between angular frequency omega I and angle theta it as omega I is equal to d theta it over dt, and we know the relationship between angular frequency and normal frequency. Hence, rewriting the above equation, we get 2 pi Fi is equal to d theta it over dt. So rearranging this equation, we get theta it is equal to 2 pi integration of Fi with respect to time. Substituting Fi value in the above equation, we get theta it is equal to 2 pi integration of Fc plus Kf into Mt with respect to time. So theta it is equal to 2 pi Fct plus 2 pi Kf into integration of message signal with respect to time. Substituting theta it value in the standard equation of angle modulated wave, St is equal to AC cos of 2 pi Fct plus 2 pi Kf integration of the message signal with respect to time. This is the equation of FM wave. If the modulating signal is Mt is equal to Am cos 2 pi Fmt, then the equation of FM wave will be St is equal to AC cos 2 pi Fct plus beta sin 2 pi Fmt, where beta is the modulation index which is equal to del f upon Fm, where del f is the frequency deviation, which is the difference between FM modulated frequency is that instantaneous frequency and normal carrier frequency. It is denoted by delta f, which is equal to the product of Kf and Am. So beta is equal to Kf into Am upon Fm. So FM can be divided into narrowband FM and wideband FM based on the values of modulation index beta. If beta is less than 1, then this is the case of narrowband FM. And following are the features of narrowband FM. It has a small bandwidth when compared to wideband FM. Its spectrum consists of the carrier, the upper sideband and the lower sideband. This is used in mobile communications such as police wireless, ambulances, taxi cabs, etc. And when beta is greater than equal to 1, then this is the case of wideband FM. And following are the features of wideband FM. It has infinite bandwidth. Its spectrum consists of a carrier and infinite number of sidebands which are located around it. This is used in entertainment and broadcasting applications such as FM radio, TV, etc. Now phase modulation. In frequency modulation, the frequency of the carrier signal varies, whereas in phase modulation, the phase of the carrier signal varies in accordance with the instantaneous amplitude of the modulating signal. So in phase modulation, the angle and the frequency of the carrier signal remains constant. This can be better understood by observing the following figures. This is the baseband signal. According to the instantaneous amplitude of the signal, phase of this carrier signal is going to be varied, resulting in the phase modulated signal. As this is clearly depicted by this figure, the phase of the modulated wave has got infinite points where the phase shift in a wave can take place. The instantaneous amplitude of the modulating signal changes the phase of the carrier signal. When the amplitude is positive, the phase changes in one direction, and if the amplitude is negative, the phase changes in the opposite direction. Now mathematical representation. The equation for instantaneous phase phi I in phase modulation is phi I is equals to Kp into Mt, where Kp is the phase sensitivity and Mt is the message signal. The standard equation of angle modulated wave is St is equal to AC cos 2 pi fct plus phi I. Substituting phi I value in the above equation, we get St is equal to AC into cos 2 pi fct plus Kp into Mt. This is the equation of phase modulated wave. If the modulating signal is Mt is equal to Am cos 2 pi fmt, then the equation of phase modulated wave will be St is equal to AC cos 2 pi fct plus beta into cos 2 pi fmt, where beta is the modulation index which is equal to del phi, where del phi is the phase deviation which is equal to the product of Kp into Am. Phase modulation is used in mobile communication systems, while frequency modulation is mainly used for FM broadcasting. Now FM modulators. There are two types of FM modulators which generate narrowband FM and wideband FM waves. So today in this session we will only discuss about the generation of narrowband FM. Now generation of narrowband FM. We know that the standard equation of FM wave is St is equal to AC cos 2 pi fct plus 2 pi kf into integration of the message signal with respect to time. So St is equal to AC cos 2 pi fct into cos 2 pi kf into integration of the message signal with respect to time minus AC sin 2 pi fct into sin 2 pi kf into integration of the message signal with respect to time. For narrowband FM, mod of 2 pi kf into integration of the message signal with respect to time is very less than 1. So we know that cos theta is approximately equal to 1 and sin theta is approximately equal to theta when theta is very small. By using the above relations, we will get the narrowband FM equation as St is equal to AC cos 2 pi fct minus AC sin 2 pi fct into 2 pi kf integration of the message signal with respect to time. The block diagram of narrowband FM modulator is shown in the following figure. Here the integrator is used to generate the modulating signal Mt. The carrier signal AC cos 2 pi fct is the phase shifted by minus 90 degree to get AC sin 2 pi fct with the help of minus 90 degree phase shifter. The product modulator has two inputs: integration of the message signal with respect to time and AC sin 2 pi fct. It produces an output which is the product of these two inputs. This is further multiplied by 2 pi kf by placing a block diagram 2 pi kf in the forward path. The summer block has two inputs which are nothing but the two terms of narrowband FM equation. Positive and negative signs are assigned for the carrier signal and the other term at the input of the summer block. Finally, the summer block produces narrowband FM. Okay, so that's all for today's session, and in the upcoming session we will discuss about wideband FM, its generation and detection techniques. And thanks for watching the video.